What is up, guys? This is Physics 2212 Lab 2 Lines of Charge. Starting it off with our table of contents, these are the things we're going to run through in this lab. And some key concepts, we have Newton's second law of motion, which states force is equal to the rate of change of momentum, and for a constant mass, force equals mass times acceleration. We have our momentum principle here. We're also going to be using Coulomb's law to calculate electric force, which is this formula, kqq over r squared. And sorry for the quality on this picture, but we have our electric field is equal to the integral of electric field formula, kq over r squared, r hat. And we're going to be integrating for each little tiny piece of, this can be used for a charged rod, and in this case, it's going to be used for a charged piece of tape. So we're going to calculate the electric field based on each little segment, or dq of, or the charge of each little segment of it. That's what we use dq for. And gravitational force, we have our formula gmm over r squared, and near Earth's surface can be simplified to mg. And some assumptions, we're going to ignore air resistance. We're going to treat a long tape as though it were a combination of point charges, which is where we see that dq in this formula. And assume that each U-tape has about the same charge evenly distributed through the length of the tape. So if we take a look at our code here, we have some physical constants, 1 over 4 pi epsilon naught g. We have the mass, charge, and distance apart between the tapes. These are the things I got from actually conducting the experiment. And we have two functions here, one to calculate the electric fields, and parameters, we have charged particle and observation location. We're going to be plugging in each charged particle, or dq, from here to calculate the electric field. And for the entire line charge, we're calculating the magnitude of each point charge, the mass of each point charge, and each dq along the line. And we use this to instantiate our line charges for the top tape and the bottom tape. And as you can see, they have about the same parameters because we assume that they are the same mass and the same charge. And going along, we're calculating force on the top tape. And so we're going from each dq on the bottom tape, the force it applies on each dq on the top tape. And getting that, when we run it, we see that this is our result. And if you look at the edges of the top tape, we have a force going this way, and then towards the middle it's straight up, and again it kind of flares outward, and that's because every single dq on this side is pushing it more this way. So yeah, now we can see physically what's going on. And these are just some of the values I got. The charge of a single tape is about positive 2.39 times 10 to the negative 8 coulombs. And some possible sources of error could be unequal charges on the tapes, maybe oversimplification of the actual physical processes that are going on, because we are simplifying it to like singular point charges. So maybe it could be more accurate if we apply more point charges, like splitting it into more dqs, things like that. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So I actually have that up right now, and we get about a similar value, but that can be because of the specific way I applied the calculations. But yeah, that goes on to the next question. Do these estimates differ? Which value is more likely to be closer to the real value, and why? The experiment that we do here, this is probably closer to the real value because it imitates more likely what a line charge would be like. Like if we assume an entire rod has its charge only from the middle, then that probably wouldn't be as accurate as actually applying a bunch of point charges along the length of the line. So this is definitely more accurate. And that was lab 2. Thanks for watching.